Hello, it's good to meet in this lecture in which we will try to cover the basic retinal imaging and we will focus on the OCT of miscellaneous retinal disorders. So one of the important resources that you need to get is the paper from the International Vitreomacular Traction Study Group. This is the QR code for that and you can access it online. The classification of this work is interesting because it enables us to grade properly the vitreomacular interface changes. So it describes what's called the vitreomacular adhesion, in which there is just adhesion between the posterior vitreous and the macula without any traction. So there is no any anteroposterior traction in the macula. And it represents as an area of gull wig appearance like shown in the photo, but without any pulling on the retina. It's furtherly subdivided into either a focal adhesion of less than 1500 micron or broad adhesion more than 1500 micron. The vitreomacular traction is similar to the vitreomacular adhesion, but there is an anteroposterior pulling on the surface of the retina by the incompletely detached posterior hyaloid. Again, it can be focal or broad, and there is what we call the full thickness macular hole, as we will see later on. It's divided into either a small hole of a minimum diameter of less than or equal to 250 micron, medium from 250 to 400 micron, or a large macular hole. We furtherly subdivide the macular hole either into with or without vitreomacular traction and into a primary full thickness macular hole or secondary to, for example, trauma or any other possible cause. Let's start to talk a bit in more details about the macular hole and the OCT findings in this condition. So the OCT enables us to differentiate between three similar conditions. The first of them is the full thickness macular hole, which is characterized by a full thickness defect of the neurosensory retina reaching to the level of the retinal pigment epithelium. There is another condition called the lamellar macular hole, in which there is only a partial thickness defect of the neurosensory retina. The remaining retinal bed is thinner than normal. This condition usually represents either an abortive macular hole, this means a macular hole that is started to develop but didn't complete to become a full thickness hole, or represents an areas of cystoid macular edema in which some of the cysts in the inner retina will open and give a partial thickness retinal defect. There is the third condition called the macular pseudohole. Here there is no hole at all, but there is an epiretinal membrane causing thickening of the macula in the perifoveal retina. And this gives this false appearance of a hole. Here there is no defect of the retinal tissue and the bed thickness is equal to a normal fovea. So the stages of the macular hole include stage 1A, or what's called the impending macular hole, in which there is a significant anteroposterior traction by the posterior hyaloid on the macula and is characterized by presence of a defect in the inner retinal layers. Stage 1B is called the occult macular hole, in which there is a defect in both the inner retina and the outer retina, but it's not still a full thickness defect. There is still a leaflet of the retinal tissue at the vitreoretinal interface. Stage 2 macular hole is a full thickness macular hole. There is a full defect of all layers of the neurosensory retina. Stage 3 macular hole, it becomes a bit larger, but there is incomplete separation of the posterior hyaloid. There is incomplete, or there is no PVD. Stage 4 macular hole is a complete macular hole with the presence of PVD characterized by the presence of a Weiss ring. It's important when you are writing the report for the OCT of a macular hole to determine what is this stage. Why this is important? Because We don't operate on stage 1 macular hole, as they have chance of 50% of spontaneous improvement if there will be a spontaneous separation of the vitreomacular adhesion. However, we start to operate in stage 2 or worse because they only have a 5 to 10% chance of spontaneous improvement without surgery. The second important thing about the OCT of the macular hole, that it gives us an indication or a clue about the prognosis of the case. So, for example, the case on the right-hand side is a case of a long-standing macular hole. We know that by the absence of cystoid macular edema at the edges of the hole and the large hole diameter. On the other hand, the photo on the left-hand side is a photo of a relatively fresh macular hole because the edges of the hole are a bit edematous with cystoid macular edema and the width of the hole is not very large. So we can say that the prognosis of closure after surgery in the case of the right-hand side is better than the case of the left. There are some indices to determine the prognosis of the macular hole closure, including the macular hole base diameter, which is the diameter of the macular hole near the retinal pigment epithelium, or the minimum linear dimension, which is the minimum dimension of the macular hole between the edges. The arms for measuring the hole form factor, which extend from the level of the base diameter to the level of the minimum linear dimension. There are the hole height, which represents the vertical height of the edges of the macular hole. There is the macular hole inner opening, representing the width of the macular hole at the vitreomacular interface. And then we have some indices, including the hole form factor, which is the result of dividing the arms for measuring the hole form factor over the base diameter. The larger the hole form factor, the better the prognosis of the condition after surgery. We have the macular hole index, which is simply the hole height divided by the hole diameter. And again, the larger the macular hole index, the better the prognosis. And then we have what we call the tractional hole index, which represents the hole height over the minimum linear dimension. And again, the larger the traction hole index, the better the prognosis. Now we will move to talk about another entity, which is the epiretinal membrane. When we are interpreting the OCT of an epiretinal membrane, it's determined to differentiate between thin epiretinal membranes, which is called the cellophane maculopathy, and they are characterized by minimal traction on the macula, and we need to differentiate them from the thick macular pucker with significant diffuse traction on the macula. And then the macular pucker may exert multifocal traction rather than diffuse traction. So in the photo in the middle, the pucker is diffusely adherent to the inner surface of the retina, while in the lower photo, the pucker is attached only to different focal points of the macular area. This is important during the planning of the surgical removal of this epiretinal membrane. We'll now talk about the third entity, which is the CSR, or the central serous chorioretinopathy. So the OCT findings suggestive of CSR include neurosensory detachment, which is characterized by separation of the neurosensory retina from the retinal pigment epithelium. Usually the edges of this area of detachment is an acute angle. Alternatively, we may have areas of pigment epithelial detachment, which presents as dome-shaped areas with right angles at the edges. Characteristically, there is no intraretinal fluid in cases of CSR. If there is cystoid macular edema, we need to revise the diagnosis and think about another alternative. And one of the findings that we need to look for in OCTs of CSR is the presence of pachychoroid, which represents enlargement and thickening of the large and the medium-sized choroidal vessel, compressing the choriocapillary maculoris as shown on the photo on the right down corner. Another interesting entity to talk about is the outer lamellar retinal defect. In this condition, there is a defect of the outer retinal layers on the OCT. The main causes of this condition include the solar retinopathy, laser retinopathy, or MACTEL type 2. We can notice that in all those conditions, there is interruption of the outer retina of the photoreceptor line. And this is an important finding to look for on the OCT of those patients. I'd like to thank you for your attention. I hope this lecture will help you to interpret the OCTs of those patients in a better way.